It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming You a Nice Coffee.
Hi guys, this video is going to be all about electrochemical cells. What I'm going to be doing is giving some background around what electrochemical cells are, some of the energy conversion involved with it, where you find it, and then I'll just show you a couple of examples as well. Okay, you will need to make sure you've got a really good handle on doing half equations. So I really strongly recommend that you look at the redox videos as well around writing half equations. Make sure you can do those pretty easily. Okay, an electrochemical cell really revolves around the fact of having two different metals that we're going to react. Okay, so we're going to have one that's more reactive and one that's less reactive. Okay, what we do in an electrochemical cell, all right, is we use chemical reactions. So we use chemical reactions. And what we do is we use that to produce electricity or an electrical current. Okay, so that production of electricity is why we can have things like batteries, okay, which produce electricity. And when we're talking about electricity in this case here, what we're really talking about is electrons. Okay, so we're going to produce electrons, and those electrons are going to be taken out via an external wire in the circuit, and we're going to use those to produce electricity. So there's a couple of things you need to understand or know about when we're talking about electrochemical cells. Okay, and the first one we're going to talk about is something called an electrolyte. Okay, an electrolyte is a solution that conducts electricity. Okay, so generally it's a liquid. It doesn't have to be though. Okay, you can have a paste, which is what you would find in normal batteries, and that allows electrons to flow through it, and that's what allows electricity to be conducted. Okay, so we're always going to have an electrolyte within our electrochemical cell. We're also going to have electrodes. Okay. Electrodes are normally metals when we're talking about electrochemical cells. They don't have to be though, but they're something that conducts electricity. They're a solid. So these ones are normally liquid or a paste. These ones are a solid. Both of them conduct electricity. Okay. The other thing that we have is something called a salt bridge. Now, a salt bridge is specifically used within an electrochemical cell to do two things. Number one, it completes the circuit. All right, so that means it allows the electrons to flow. And it does that by the second thing, which is maintaining a potential difference within the cell. So it balances up the gain and loss of charge at each of the electrodes. Okay, so I'll explain that a little bit more. Now, within the electrodes, we've got two types of electrodes that we can be looking at. Okay, and we're going to be looking at the cathode and the anode. Okay, so I'm going to bring both of those in, okay, and I'm going to explain about, in terms of electrochemical cells, okay, how you work out which one's the anode and the cathode. There's a couple of little acronyms which I need you to remember as well. Okay, so the first acronym that I'm going to look at is the one which hopefully, I haven't used that before, sorry, is the one that you should have known already from the half equations, and that's the one which is your oil rig. Okay, so this is the one which says that oxidation is a loss of electrons, reduction is a gain of electrons. So you need to be able to understand that when we're looking at our half equations. Okay, the next one I'm going to be looking at is this one called GAN-EAP. Now this is one a student of mine came up with a couple of years ago, so I can't claim credit for this. But GAN-EAP is something you can use to work out the polarity at each of the electrodes. So in a galvanic cell, which is what an electrochemical cell is, and I should have mentioned that earlier, that electrochemical cells are also called galvanic or voltaic cells. They're exactly the same. In a galvanic cell, the anode is negative. Okay? In an electrolytic cell, which will be the next video, the anode is positive. So if you remember GAN-EAP, that helps you to work out positive and negative electrodes. Okay? Final one which I need you to remember is your vowels. So O and A, all right, your vowels go together. Oxidation is at the anode. Okay, and obviously reduction is at the cathode. So your vowels and your consonants go together as well. So if you can remember these three things when we're going and looking at electrochemical cells, you should be able to work out what's happening within the cell pretty quickly and easily. All right, so let's have a look at a typical galvanic or electrochemical cell, have a look at what's happening within it, and start to identify some of the components of it based on these three things. So I'm going to draw up a cell which is just going to use two different metals. Remember, we use metals of different reactivity because that way we then get electrons to flow between them. So an electrochemical cell is made up of what we call two half cells. Okay, so we've got one half cell here, okay, and then we've got another half cell over here. Okay, so we have two half cells within our whole cell in particular. Okay, now these half cells both are filled with an electrolyte. Okay, so our electrolyte goes inside here. Those two like that. And then we put an electrode inside each of them as well. So here's our electrode. This is our solid material that conducts electricity. So these are our two electrodes. So that's the basis of our cell. Now what we do, all right, is we use the difference in reactivity between the metals within here to produce electrons. Now those electrons travel through an external wire. And the way that we normally would set this up is you'd have like a light bulb here or something which is going to use the electricity. When we're just talking about drawing up a general cell like this, we generally put something up the top here like a voltmeter, an ammeter, a galvanometer. So you'll see a V, a G, an A up there. Sometimes a multimeter, all right? Doesn't really matter. All that means is that we're actually recording the current that is produced because we're using chemical reactions down here in the half cells to produce electricity, which goes through the external wire. So that connects them up. All right, and then the final thing that we need is a salt bridge, which is what comes through here. So the salt bridge connects the two. And I apologize if this is a little bit smaller, but that's our salt bridge in there. So this is our electrochemical cell. Okay, we've got two half cells which contain an electrolyte, which is a solution that conducts electricity. We've got electrodes that sit inside it. They're connected by a salt bridge which completes the circuit and maintains a potential difference. And we've got an external wire which is where the electrons flow. So what I'm going to do is I'm going to rub out each of these names so we can actually look at these two metals without having such a cluttered diagram. Okay, so here's our electrochemical cell now without all those other names and labels on there. Okay, just so we can start having a look at what's happening. So I'm going to use two metals in this one. What I'm going to use is for this electrode here, I'm going to make this some zinc, like this, okay? And for this electrode over on this side, I'm going to make this one some copper. All right, so we've got a zinc copper electrochemical cell here. So what that means is our electrolytes, we generally use the sulfate salt, all right, of whatever metal we've got as the electrode. The sulfate is unreactive. So that means here our electrolyte in here is going to be copper sulfate. Okay, and our electrolyte over in this one here is going to be zinc sulfate. Okay, so both of those will conduct electricity. Both of those will allow reactions to occur in each of the half cells. So the rule of thumb that you always need to remember when we're going through and doing our electrochemistry, all right, is this. Okay, the most reactive metal, okay, most reactive metal is the anode, always. Okay, most reactive metal is always going to be the anode. So what that means is in here we've got zinc, we've got copper. Zinc is far more reactive, so that means that this over here is going to be our anode. Okay, and I'm just going to focus on the zinc here for a little bit first. So that's our anode. Now we come back to those three things I told you earlier. Okay, so we're talking about oil rig, remember that? And then I said GaN-EP. In a galvanic cell, the anode is negative. So this is actually a negative electrode right here. Okay? And remember your vowels go together, O and A, oxidation at the anode. So this is also where oxidation occurs. Okay, so oxidation here at the anode, which is our negative one. And we know that zinc is our anode because it's the most reactive metal. Okay. Over here for our copper, okay, copper is less reactive, okay, so that's going to be our cathode over here, okay. The cathode is opposite polarity, so it's positive in this case here, and the cathode is where reduction occurs, okay, because your constants go together, so reduction over there. All right, so just by getting the two metals, we can quickly work out what's happening at each of them. Okay, here the anode we knew was a zinc because it was the most reactive metal. That means it's negative because of GaN-EP, galvanic cell anode is negative, and your vowels go together, oxidation at the anode. Okay, over here cathode is going to be positive, opposite polarity. It's the less reactive metal. It's where reduction occurs. Okay, so what's happening within this cell, okay, is that this here, all right, the zinc one is going to be undergoing oxidation. Now, that's where your oil rig comes in. Oxidation is a loss of electrons. So what we're going to have happening is our zinc metal, there, our solid zinc metal, is going to be forming zinc ions, Zn2+, and we're going to be adding electrons in as well. So that's our half equation occurring at the anode. Okay. For our cathode, all right, we've got reduction occurring, which is a gain of electrons. So the copper ions inside solution here are going to be picking up electrons and forming solid copper. That's our reaction at the cathode. Okay. So what we have happening is oxidation at the anode. The zinc is losing electrons. Those electrons travel through our external wire up over here. So the electrons are flowing from our anode, so they're actually flowing this way. The electrons are flowing from our anode over to our cathode through the external wire in the circuit. Okay? The copper ions in solution down here are picking up the electrons to form solid copper. Okay? Now, the last thing that we haven't looked at is actually our salt bridge and what's happening here. Now, the salt bridge can be any number of different things. All right? For this one here, what I'm going to use as our salt bridge is some potassium iodide, aqueous potassium iodide. Now, the potassium iodide is made up of potassium ions, which are K+, all right, and it's made up of iodide ions, which are I-. Okay, so we need to work out what's actually going to happen with these different ions and where they go within the reaction. So have a look here at the anode. What we're doing is we're building up positive charge of the zinc 2+. So that zinc 2+ is going to be building up here within this half cell at the anode. And we're going to start getting quite a positive charge building up. So what's going to happen is that the iodine ions from here are actually going to move over to this electrode to counteract or balance out that zinc, all right, the positive zinc. So the iodine goes down here into the anode. Now that's an anion because it's negatively charged. Anions go to the anode. Okay. The potassium ions here, over in the cathode, we're actually losing positive charge. So the positive potassium ions are going to come down here to the cathode, so the cations towards the cathode, to replace the positive charge which is lost. Okay. So our potassium ions here go down towards the cathode. So cations to the cathode, anions to the anode. So that is an electrochemical cell, using a difference of reactivity between two different metals. So it doesn't matter which metals you use. We could swap these over to be iron and lead, for example, and the most reactive metal would be the anode, and then you just get the same sort of things occurring. Negative at the anode through GAN-EP, oxidation at the anode because of your vowels. Okay? So it's the same sort of thing every time. So what I suggest you do is you have a look at this video a couple of times. You might want to pause it. You might want to maybe pick two other metals and try and draw up your own electrochemical cell. Try doing your half equations as well, remembering the most reactive metal always loses electrons, and then try and work out which one's positive, which one's negative, and go from there. All right, hope this is helpful. I know it's a lot of information I've tried to pack in here, so you're probably going to watch it a couple of times. Once you've done that, I recommend you go on and you have a look at the one on electrolytic cells so you can understand the difference between them. Thanks, guys.